Welcome to my next tutorial. In this tutorial series, we shall be looking at deep learning, and I'll quickly explain some important concepts in a way that is easy for people to understand. I know there are a lot of tutorials out there, but I will be concentrating on some aspects of the deep learning tutorials which uh, I find it difficult to understand, even considering the number of tutorials that we have out there and the materials out there. So I won't be explaining all in details, but I will just focus on some of the areas that I feel I can better explain the concept for someone to be able to understand it. So hopefully today we'll look at introduction to deep learning. We look at the basics of machine learning, we look at linear regression, and we look at gradient descent. So um, the question is, can you explain the difference between humans and computers in terms of tasks they can or cannot achieve? There are some tasks that humans are good at. There are some tasks that computers are best at. So, what's the difference between humans and computers in terms of the tasks that they can or cannot achieve? You may pause to take a look to answer that yourself. But one thing you will discover is that humans are very good at vision. We are very good at seeing objects and recognizing the object. We're very good at seeing multiple objects and recognizing them and their spatial location from other objects. So we're very good at that. Humans are even very good at seeing object and measuring how fast the object is with the eye compared to other moving objects. But it's difficult for computers to just pick an object and be able to recognize that. So that is one, and there are several others. Now, how is deep learning different from standard machine learning? You will see this in many tutorials that deep learning essentially allows you to be able to just feed in your data, bunch of data during training, and you can just get your output without having to do any feature engineering. So the basic idea is that you don't have to manually select the features that are important or not important to whatever it is that you want to, whatever task it is that's of interest to you. Um, and when I say feature engineering means, for instance, if you want to classify maybe a transaction as fraudulent or not fraudulent, you may want to get some attributes of that transaction. Maybe a particular IP address may be very important for you to be able to categorize the transaction as fraudulent. Maybe there are some known IP addresses that have been identified for malicious transactions. So you may want to feature engineer that you need the IP address of all the transactions to be able to detect that. And you might have to look at maybe the credit card type, maybe another feature that is useful. So you have to be a domain expert. You have to understand the area, the field, for you to be able to actually pick the features that will be of importance to doing the tasks that you have to. But with deep learning, you don't need to do that. You just need to feed in all the features that you have. Hopefully the important ones are also included, and both important and unimportant features can just be dumped together, and you expect that your deep learning model will be able to figure out what is important and what is not important in doing the classification or in predicting the output of your task. So let's look at this. Deep learning is a subfield of machine learning. Machine learning is a subfield of artificial intelligence. Artificial intelligence generally is trying to build machines that will be able to surpass humans. And machine learning is a subfield of AI. what machine learning is. We don't want to code the machine. We want the machine to actually learn from data. So we give the machine a lot of data and we allow it to figure out what is important for to do the task. So the machine is actually learning from data, learning a pattern from data. Most machine learning methods work well because of human designed representation and input features. For example, if you are to find a named entities like locations, organization name, you have some features that are very important, and you will see that these are the features that are important. So you need to be a domain expert in this field for you to be able to know which features will be important to do a name entity recognition. And talk about name entity recognition, you're trying to find the name of a person, the name of a location, the name of a company, the name of a city, like that. So that's what we mean in a bunch of sentences. So these are some of the features that might be very important for you to be able to perform that task. You want to know what is the next word, what is the current word, what is the previous word. So machine learning can be seen as just optimizing weight to make a best final decision, and we're going to see more about this as we proceed in this tutorial session. When you talk about weight is just a bunch of numbers, that are put into a list of lists, which you call tensors or matrices. So you just optimize. That is, optimizing means you keep changing, adjusting the numbers to be able to suit the best possible that you can have. Okay, now the traditional machine learning, you describe your data with features that a computer can understand, like I said earlier, and you also optimize the weight with using your learning algorithm. But in deep learning, which is actually came about as a result of we picked the inspiration from how the brain learns from neurons from human brains. And so deep learning is when you stack a number of neurons together. We call it stack of layers together, then you form what we call the deep learning. So that's the deep, having multiple layers of neurons. Essentially, when you have more than one layer, then you call it a deep neural networks, deep learning. So representation attempt to automatically learn good features or representations. You see in this place, the X represent our input, and the X, each of these node is represent a feature that is from your data. Maybe for instance, the credit card type, the IP address, each of them represent that. And so these are the layers, the H1, H2, H3, each of the layers, and in each layer you have multiple neurons, and each of those neurons is learning a particular representation from your data. Okay, so deep learning attempt to learn representation from an input. That is, one particular neuron in your layers may actually be focusing on how well is the IP address affecting the output, or how well is the credit card type affecting the output, or how well is the email address affecting the output, or how well is the time of transaction affecting the output. So each of these neurons is responsible to learn different features. Now the final layer is the output layer. In this case, we have just one, which is actually maybe a yes or no or true or false kind of classification or predicting a particular number in what we call linear regression. So from our raw input X, which could be words, which could be images, which could be audio, which could be videos, and so there are multiple kind of input data that you can have there. Now, yeah, we focus on different kinds of neural network and the dominant model family inside deep learning. While we're exploring deep learning, why? Because to manually feature engineer is very difficult. If you don't have domain knowledge, it takes a long time, and you cannot even imagine all the features that you might possibly need to be able to uh, use in performing your tax classification or, or predictions. So many times they are just too specific to a particular domain. So for each domain, you are working in credit card, you have to do feature engineering for that. You are working in another domain, maybe you're trying to detect defect in steel or defect in brakes in the automobile, or defect in maybe fluid pad or wherever. You have to start doing another kind of domain expert feature engineering. So it's too specific to a domain. But when you use deep learning, it's easier for you to quickly learn and adapt. Deep learning is flexible, uh, learnable framework for representing the world. And deep learning can learn unsupervised, that is where you don't put a label, and you can also use for supervised, where you have a label to each of your data input. Why is deep learning so successful? You may pause to find out the answer yourself, and if you have done so, the reason are just two: you have a lot of data, and you have um, high computational power. So you have greater computational power, and now we still have better algorithms now that are being developed. So that is it. Now we have improved performance now in speech recognition, natural language processing, machine translation, and all others. Now, more data improves performance. That's not generally true, but we see that in most application domains, the more data you have better performance in your accuracy, in your F1 scores, and some other metrics that you might use to be able to evaluate your classifier. In this picture is showing us that you have the larger your neural network, and when you say larger, it's talking about the deeper your neural networks, or the wider it is, and the better with increase in your data, the better the performance. Deep learning for speech. So you have this paper, context-dependent pre-trained deep neural network for large vocabulary speech recognition. And so this is actually where you can actually recognize a speech using deep learning. And this is the first application of deep learning to speech domain. And you can see the measures, the performances over there. You might want to take a look at that paper, and with time we will also be taking looks at some of these papers and see what are the content of these papers, so that we can best understand how deep learning were used. You have speech recognition system on Alexa. I'm sure you know what you mean by speech recognition, where you can also speak to a phone or your device, and your device can actually respond to you and do whatever you want done. Instead of typing, that you can actually just speak and get the same thing done. So like you have Alexa, you have Siri, you have Baidu, you have some others application systems that are being used in speech recognition. Deep learning for computer vision, you have the ImageNet paper, where you actually have over 1,000 categories of kind of images that are used for classification, and you now have deep learning for computer vision, making a very great success in classifying images and predicting what type of image you have in a picture. These are some of the results of the ImageNet classification paper. And if you look at this lens, this is the picture of a lens lamp, and these are the predictions that you can see in like blue color here. So this is the top 5 predictions that you have. This is you have n top 5 prediction. So this is the predictions from the model. In this situation, you see that the model actually got the uh, the the picture correct, as in when you have the name of the picture predicted in the first 5. You see the slug is here, you have abacus is here, lens camp, you see this was missed, so this is completely missed. So the blue represents missed, the like pink color shows that the model got it correct. So tiger got it correct. Chamber nauticus, you missed this one correct. Absolutely. It also missed a player. This was missed, and he got this one correct. Planetarium. Mapping images to text. This is another area where speech record. And deep learning has done good. Well, you can actually take your image and tell what it actually is, just like quite quite close to what you can refer to as image captioning. So you have an image and you can tell us what is that image. So for instance, here you have a backward red flower, so you can see it. So it's like taking your picture and telling us what is it. So taking picture into text. So yeah, this is a bottle of water, this is a glass of water with iced lemon, this is cup of coffee, and then you can say, okay, this is a house, or this is a car, and this is a road, or this is a fish pond, or something like that. Now, image caption generator, this is just what I said earlier, whereby you give an image and you try to make a sentence from that image. For instance, this is an input image and we want to say that, okay, a bird flying over a body of water. So just giving us a small summary of what the image is. So you can build a model that will look at an image and give us a summary, make a story on that particular image. And this is the deep learning architecture being used, which is both a CNN and RNN, which we see later on. We also see deep learning doing a great work in question answering system, and this is IBM Watson, which actually had the best quiz in a quiz IBM Jeopardy quiz program, and you see that the IBM Watson actually did very, very, very better than other human performance. What's this course about? We want to learn the basics and the thing of deep learning, how to use pre-trained training your own deep model, and how to apply deep learning model to textual images and other data. So a little refresher on the machine learning. So there are some basic things you need to understand in machine learning, which will build up into deep learning. So we look at linear regression, logistic regression, graded descent. So if we look at the 3 fundamental problems of learning. Now, when you talk about regression means you're trying to predict a number. Yeah, maybe you're trying to say the price of a house is $24,000. You're trying to predict the price of a car is $10,000. So that's just a continuous number. You're trying to predict the cost of maybe a shoe or something. In classification, you're trying to predict a discrete, that is a discrete labels. So it's either yes or no, it's either true or positive. You have a category bucket of output that you just want to predict. So you don't have infinite category, you have a specific category, predefined category that can fall into. You also have unsupervised learning, which could be learning to group objects into categories. You may have to like give you a bunch of students, and like we ask you to group them. So we are not telling you anything about the student. You just give you information about the student, their name, where they are from, the school they are, and we ask you to just group them. So how are you going to group them? Is it by school, or by where they are from, or by gender, or by sex, or whatever? So that's an unsupervised learning. We just did not give you any label. You just have the features, and you have to predict. You have to cluster them. So this is a regression. Here we have all these in circles as the data point. So these are data points, and you want to draw a line, best line of fit into that data point. And this can actually, you can write a mathematical equation which is sine 2 pi x, which will give you this green line. This green line will give you a best line of fit into this data point. When I say best line of fit, we want to draw a line through this data point that will be the best to each of the data point that we have. Yeah. These are linearly separable classification problem. Yeah, you have the red data point, you have the blue data point, and you want to separate the red from the blue, so you can just draw a straight line. That is why we call it linear, and you can classify those data points easily. So if you have a new data point that comes in anywhere, you can easily say, okay, whether it falls, whether you will categorize that new data point as being part of the red or as being part of the blue. Unsupervised learning, this case we didn't tell explicitly what each of the data points are. Here we can, the best way of even depicting this is we're not even showing it as red, or we're not showing it as blue or anything. We just show, as you have in this part, you just show in this area that, okay, we have this data point, you have this data point, what can you do about it? So the best way is just all these ones are close together, these ones are close, so just draw a circle around. Okay, that's, you have clustered the two data point. This is in the unsupervised learning. But in the supervised, we actually told you something about each of the data points, so you have a label for that. Linear regression with one variable. When I say variable, it's actually synonymous to like saying your features. So here you have your input variable as x, so you just have one input variable, and you have your output variable as y, and what you're trying to do is predict a number, a continuous value for y. So here is the data point. You're given different type of training data point. If x is this, you have the y. 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 So you already have relationship between x and y in this in your given input data. So what you want to do, you want to learn a function, hopefully a function that is as close as the exact function that will model this data. So, and that function is actually a straight line function into the data. So this linear function gives you a relationship between the input and the output data. So you have the linear regression line, so it's a straight line that is drawn into the data that will give you the best fit into the data point. So we're going to stop here. In the next session, we'll continue from this place. Thank you for listening. We'll see you in the next one.